What do you first think of when you hear the words parallel universe? Many people associate it with science fiction, something that's made up to make things sound futuristic and cool, along with other words thrown around there like nanotech and quantum mechanics. But what if I told you that the possibility of parallel universes is there? What if I told you that it's very plausible that they exist? In quantum mechanics, if we know the quantum state of a particle, which is its wave function, then we can use the Schrödinger equation to figure out what this particle will be doing in the future. Quantum mechanics has this really interesting thing called entanglement, which basically means that if two particles were to interact with each other, they could now be described under a single wave function. Take the famous Schrödinger's cat experiment, for example. In that experiment, a cat is placed in a box with a radioactive atom and a radiation detector, which is created so that it releases cyanide gas when it detects radiation. In that case, if the radioactive atom decays, the radiation detector will go off, it will release the gas, and the cat will die. If the atom does not decay, well then there will be no radiation detected, no cyanide gas released, and therefore the cat will be alive. In that experiment, the state of the cat, alive or dead, is directly entangled with the state of the atom. And according to quantum mechanics, the cat is both alive and dead, so in a superposition of states. That is, until we open the box and observe either the cat is alive or the cat is dead. But wait a second, when we are taking a measurement, aren't we also getting entangled with the quantum state of those objects that we are measuring? Because we are technically made up of atoms and everything that makes up atoms, so we are technically quantum mechanical. So we can say that there is really no measurement. And so the superposition continues. Going back to the Schrödinger's cat experiment, we are in a superposition of seeing the cat alive and seeing it dead at the same time. But that sounds even weirder than everything else we've just talked about so far, because I've never seen anything that's simultaneously dead or alive. Well, that's where the whole parallel universes things comes in. You see, this is an interpretation of quantum mechanics called many worlds. And basically what it means is whenever a particle gets entangled with another particle, the universe splits into two, if you will. Therefore, when we see the cat dead and alive at the same time, we are seeing it in two separate timelines. And now imagine that this splitting of the timeline happens whenever a particle interacts with and therefore gets entangled with another particle. Air molecules and everything in our environment interact with each other at almost an infinitesimally large rate if we look at it from the very beginning of time. But the thing is, you'll never interact with these different timelines. You're just going to be living out your own timeline because of all of the specific particles that happen to interact with each other in your timeline. So now you say, well then how is this useful? There's infinitesimally many copies of you, or rather versions of you, and you can't interact with them, they're all more or less the same. Well, it's really not. We're just going to be living in our own timeline, interacting with our own series of particles, and being entangled with them. And during these troubling times, I think it's a good idea to have in mind that we're all actually the same wave function.